Hello, today we'll be finding arithmetic sequences. We will be figuring out which ones of these sets right here are arithmetic sequences, and then we'll be able to learn how to write them explicitly and recursively. So, first, what is an arithmetic sequence? An arithmetic sequence is one where each successive term is a fixed amount larger than the previous one. So that's pretty fancy. So it just basically means that there's a way that these numbers get bigger and it's going to be the same fixed number. So for example, let's just get started in our first example. So to get from negative 11 to negative 8, we need to add a positive 3. And now my pen doesn't want to work. There we go. Now add a positive 3. And now to get from negative 8 to negative 5, we need to add a positive 3 as well. From negative 5 to negative 2, we need to add a positive 3. So this is an arithmetic sequence because each successive term is a fixed amount larger than the previous one. So the successive terms is negative 11, negative 8, negative 5, and it's a fixed amount, the positive 3. So the way we'll write this is a sub n, as this will go on to infinity, it has no end, with n equals 1, with a sub n. So our first term is negative 11, so it will equal negative 11 plus our fixed term that we're adding is 3 plus 3, and we're going to add 3 one less times than what we're at. So that'll give us n equals 1. So then for the second term, we add 3 once. For the third term, we add 3 twice. So that's how we get n minus 1 right there. And that is how we write it explicitly. Now, if we wanted to write it recursively, we'll have our first term, a1, which is our first term, a, those are our a values, a1, equals negative 11. And then a sub n, which is our next number, will equal a sub n minus 1 plus 3. That's because our number we're adding is 3, and it's still the same reasoning behind that for the n equals 1. And that's for n is greater than or equal to 2. So that is how we write it recursively. There we go, let me straighten it out. That's how we write it recursively, and this is explicitly. So I'll draw a little line there separating those two, and those are two correct ways to write it. Just writing it in two different ways. So we'll put a smiley face right here, since yes, that was an arithmetic sequence because it was increasing by 3, our same fixed number. So let's go on to our next one. So to get from 75 to 79, we needed to add 4. That was why I said 4. So to get from there to there, we need to add 4. To get from 79 to 83, we need to add 4. To get from 83 to 87, we need to add 4. Boom, another smiley face. That is another arithmetic sequence because we are increasing with a fixed amount. So, same exact way how we will write it. So our a sub n, and this has no n, so it's going on till infinity. For n equals 1, with a sub n, our first term, 75, plus we're increasing by 4, so that will be plus 4 and minus 1. So it's not that bad once you get a hang of it. So that's how we will write it explicitly. And if we want to write it recursively, it will be a sub 1 equals 75. And then to figure out our next term, a sub n equals a sub n minus 1 plus 4. And that's how we will write it recursively. 4, let me add in 4, and is greater than or equal to 2. Once again, both of these are right, and they're saying the same exact thing, just different forms. One's the explicit form, one's the recursive form. The explicit form, the recursive form. So let's see if right down here now we have another arithmetic sequence. So to get from 1 to 4, we need to add 3. Now to get from 4 to 8, we need to add 4. So we can tell already this is not going to be an arithmetic sequence, because our value that is changing, it seems like it's going to be increasing by 1. You get from 8 to 13 plus 5. Yeah, so it's now plus 3 plus 4 plus 5. So this is not an arithmetic sequence, but we might as well try to write it. So this one, we can write this one recursively. So what we will do is we'll do our first term. Well, first a sub n. It's going on to infinity. Our first value is 1 with a sub 1 equals 1. First term is 1. A sub n equals a sub n plus 1 plus n. So it is your previous term plus what your index is, because on your other ones your index didn't change. So we needed to add the index to it because our index is ever changing. So that one gets a little more confusing. We'll give that one a frowny face because that is not an arithmetic sequence. But now that we've done 2 examples of what arithmetic sequences are, there's a formula now behind it to where I could have told you guys that at the start of the video, but I feel like once we got a couple examples in and you realize, oh, there's a pattern to this, and you plug it in, then that makes the formula a lot easier to comprehend with a bunch of variables in it. Because that's how I personally like to learn, is rather than get given a formula, figure out what the formula is so the formula makes sense to me. So our same a sub n, and it's a sub n equals k, which is k is our first value. So here k is negative 11 for that example. Here k is 75. So a equals k plus d, which is our fixed amount that is increasing, which it can be decreasing too. I could have given this one where it was negative 4, where we were decreasing by 4. So instead of plus d, it could be minus d. And then lastly, our n minus 1. And that is for our explicit definition. And then for our recursive definition, it is a sub 1 equals k. Same thing, 75 or 75, k to k. A sub n equals a sub n minus 1 plus d. D is our number right there, which it is increasing by. So there's our plus 4, plus 4, plus 3, plus 3. And again, if that was minus 4, that would be minus 4 right there. 4 n is greater than or equal to 2, because it needs to You can't say it the same exact number. That's why we have n is greater than or equal to 2. So that is how you figure out arithmetic sequences and how to write them explicitly or recursively. Thank you.